Okay, good morning. Welcome to
FamilyMath124b.
124b. Yesterday we did a cool fawn wind problem about bridges, right?
Yeah.
And that was kind of a strange problem about people walking around with flashlights on bridges that were about to blow up.
Yeah.
So it was a little contrived. So this morning I was thinking like, hey, there's a couple cool problems about bridges. And I think I want to show you this one and I'm going to show your brother the other one. Okay? Mm-hmm. So if you're ever on a bridge, you'll notice at the end of the bridge there are these little metal things called expansion joints. And what that happens, what they're for is if it gets really hot or really cold, the bridges can expand or contract a little bit. Okay, and if they're not able to expand or contract, what they'll do is they'll bow up like this. And that's kind of a problem, right?
Yeah.
Like you wouldn't want to be on the bridge if it suddenly went whoop. Okay? Yep. So they need to be able to expand and contract a little bit. And what we're going to do is we're going to say, imagine there's a 1,000-foot long bridge. And it just expands 6 inches. Okay, 6 inches of expand. So 3 inches on this side. 3 inches on this side. And you can see that if you don't allow it to expand, the only thing it can do is bow up like that. Mm-hmm. Okay, so we're going to look at it from the middle. It's going to be 500 feet. And it's going to expand 3 inches. And we're going to try to figure out how high it is in the middle. Okay? And just before we do that calculation, what would you guess?
I'd guess around a foot.
1 foot. Okay? So that's your guess?
Yep.
All right, here we go. Let's go figure it out. Okay, so here we are. We're gonna we're at the whiteboard, and we're gonna talk about how if you have a 1,000-foot bridge,
yep,
and it just expands by 6 inches,
yep,
how much does it bow up? Okay. So what we have is a bridge, and then it expands a little bit, but it can't push out at all, and then it just bows up like this.
Yeah.
Okay. So what we're going to do, just to be very simple about this, is approximate it by a right triangle.
Yeah.
Okay, because that's a close enough approximation for now.
Yeah.
And it's especially good approximation when the only thing we know about geometry so far is what?
Triangle.
About triangles, yeah. So we don't really know how to calculate the lengths of arcs of circles yet.
Yeah.
But that's okay. So we have...
This side is 500.
This side is 500. Because the bridge was 1,000.
Yeah.
This side is x. This is what we're trying to calculate, how high it bows up. And I asked your brother, by the way. This side is 500 plus 3 inches. And how much of a foot is 3 inches?
It's a quarter of a foot.
So we'll just call this 500 plus 1/4 to keep everything in feet. Okay?
Yep.
So how high do you think this is? If this whole bridge expands by 6 inches, this one side expands then by 3 inches on that side. How much do you think this is going to bow up, the bridge in the middle? Just this tiny little expansion. How high do you think it's going to be in the middle?
Well, if it just bows up, well, it might. I think it's going to be less than 500 feet.
Oh, it definitely will be less than 500 feet. But it's just, remember, it's 500 feet long and it's expanding by just 3 inches on this side, 3 inches on this side. So it's going to push up a little.
Yeah.
You have any guesses how much?
Well, maybe 6, maybe a half of a foot.
Half a foot. Okay, so you guessed 1 foot, right?
Yep.
You guessed half a foot. So what does our Pythagorean theorem say?
A squared plus b squared is c squared.
Okay, so we have 500 squared plus x squared. That's what we're trying to find. That's the height, right?
Yeah.
Equals 500 plus 1/4 squared. Now, I haven't talked with you about how to evaluate this 500 plus 1/4,
No.
but I have talked about it with you.
Yep.
Okay, so what does this side equal?
Well, it's going to equal 2,500.
All right, let's just write that as 500 squared.
Okay.
Okay, so what we're doing here is we have to multiply 500 plus 1/4 times 500 plus 1/4. So the first thing we do is we multiply 500 by 500.
Yeah.
So we get 500 squared. Okay, what else do we get?
We get a quarter of 500.
Okay, which is what?
Well,
Which,
Do you know what a quarter of 500 is?
I know what a fifth of it is.
Okay, a fifth of 500 is
Oh,
100.
Yeah, so this is gonna.
Well, we have two. Whatever it is.
125.
125, very good.
Yeah, well, whatever it is, we have 2 times it.
We have 2 times it. Because 500 times a quarter, and then, sorry, 500 times a quarter, and then 1/4 times 500.
And plus 1/8. A fourth, 1/16.
1/16. Okay. All right. So I have 500 squared plus x squared equals 500 squared plus 250 plus 1/16.
Well,
Okay.
the 500s can go away.
Right. The nice thing is when we have the same thing on each side of an equation, we can just cross it out. That's just about what we're going to start studying. Okay? And the 1/16 is really small compared to 250, right? So
Yeah.
we're going to say x squared, our height, is about 250. And what number squared is about 250? You probably have a good guess. You may.
Well,
12.
12 squared is 144.
yeah. So, maybe 15, maybe 16 squared.
What is 16 squared?
That would be 256.
All right. 16 squared is 256. So the height is about 16 feet.
Wow.
Wow.
Whoa! Now wait a minute. We just said the whole bridge expanded just by 6 inches. It's 1,000 feet long, and it just expands by 6 inches. That middle pops up 16 feet.
Whoa.
Whoa! Would you like to be on the bridge when that happened?
No.
You'd probably be ejected like splash into the water.
Yeah.
So that's why they have those expansion joints. Because if they didn't have those expansion joints,
It'd go popping up.
it would go popping way up. And even just a little tiny bit of expansion.
Would just make it pop up.
You thought it was going to be 1 foot. You thought it was going to just be 6 inches. But it turned out to be 16 feet.
Whoa.
Whoa. Okay, that's pretty cool, right?
Yeah.
All right, that's one neat bridge problem. And I'm going to do a second one in just a second, okay?